Okay, welcome back, Algebra All-Stars. Hope you guys are still feeling good about what's going on in class, what we're doing here. We're kind of in the middle of our polynomials unit. This video is going to cover multiplying and the many number of ways that we will face multiplication with polynomials. And then your next one will be dividing, and then we'll be done with the unit, basically. So halfway there. All right, we're going to jump right in. When we are talking about multiplying polynomials, you know that there's a bunch of different classifications of polynomials. So we're going to kind of take this stage by stage in terms of the multiplication. The easiest one and the most straightforward one is just multiplying one monomial by another monomial, just a term by a term. The cool thing about multiplying, and I know I have, it's going to be very contradictory to what we've talked about before, because I've kind of hammered into your head so far that you can only combine like terms. Well, when you multiply, that rule goes out the window. You can mash together anything you want. You can only combine like terms when we're talking about adding and subtracting, but when we are multiplying, those rules do not apply. Okay? We are just going to get the product of whatever we are faced with, and we don't have to worry about things matching. So the first thing we're going to look at, monomial by monomial, 3x squared times 4x. This is super straightforward. We're just going to examine the different parts of the problem. We've got the coefficients, and those need to be multiplied together. 3 times 4. All right, 3 times 4 equals 12. Then we're going to multiply the variables together, and if we remember our last lesson, when we are multiplying like bases, we add the exponents. So x squared times x to the third is the same thing as saying x2 plus 3, which gives me x to the fifth. So I've got 12 and x to the fifth, and now I need to put those pieces back together. My answer, 12x to the fifth. Simple, right? We got this. This is no problem. Let's look at 2a squared b cubed times negative 4a to the fifth b to the fourth. Okay, well this might look a little more complicated because we've got two variables with exponents on each of those terms. But you guys, it's still one term times one term. We got this. Let's look at the parts. Coefficients. 2 times negative 4. That's going to give me what? Negative 8. Okay? Then let's look at the a terms. A squared times a to the fifth. That gives me a2 plus 5, which gives me a to the seventh. And then b to the third times b to the fourth. That's going to give me b3 plus 4, which gives me b to the seventh. So I've got negative 8, a to the seventh, and b to the seventh. I'm going to put it all together. Negative 8, a7, b7. Let's look at this last example over here. X squared. Now I'm going to zoom this in just a little bit so it's a little bit easier to see. At least I think I am. Here we go. Okay, there we go. That's a little better. All right, x squared 7x cubed times xy. X squared 7x cubed times xy. Let's multiply our x's together. We've got x squared and x. X squared times x is the same thing as saying x2 plus 1 because we can't forget when there's no exponent, it's understood to be a 1. If you're raising something to the 1 degree, you're not multiplying it by anything. It's just there that one time. So that's going to give me x cubed. Then I've got 7y to the third times y, which is the same thing as 1y, right? So I can multiply the 7 and the 1 together to get 7. But those need to stay stuck to the y because that's how they got here. So now y cubed times y1. Altogether, that's going to give me 7y to the fourth. So my answer, x cubed 7y to the fourth. Technically, we should be writing this in descending order, right? Based on the degree of the exponents. And if we want to do that, it would be 7y to the fourth x cubed. That wouldn't change the value, because remember, multiplication is commutative. It doesn't matter what order the terms are that we're all multiplying together. 1 times 7 and 7 times 1 equals the same thing. So we can put the 7y to the 4th times x to the 3rd. We can put the 7y to the 4th first. It just has to stay stuck to the y because that was where it came from, up here. All right, so that's monomial times monomial. We'll do a lot of practice of that in class, but like I said, pretty straightforward. Okay, when we're talking about a monomial times a polynomial, the key here is something that should be very familiar. When we talked about properties, this is something that you've been doing since the very beginning of multiplication, and that is what? Distributing. The key to monomial times polynomial multiplication is to distribute. I can't spell and talk at the same time. Yikes. All right, so 4x times 2x squared minus 3y. So we have to distribute the term outside the parentheses to the first term inside. So we'll go the first term, which is 4x times 2x squared. That's going to give me 4 times 2 is 8. And x to the first times x squared. We're adding those exponents. We get x cubed. Okay, now we have to take that 4x and we have to distribute it to the second term inside. And I put a little asterisk here in your notes because, you know, you want to be aware that you're going to distribute those terms until there's no more terms to distribute them to. So if there's more than 2 terms, you just keep going until you get to the last one. There's no hard and fast rule that says stop at the second term. But for this one, we only have 2, so we only have to distribute it to 2 things. We'll have 4x times negative 3y. Now, does it matter that we don't have the same variable here? Absolutely not, because this is multiplication and we can mash anything together that we want to. Isn't that fun? 4 times negative 3 is going to give me negative 12, and x times y is going to give me xy. Kind of silly. All right, so now we're going to combine these things back together, and we get 8x cubed minus 12xy. We can do no combining of any like terms here because there are not any like terms. We'll see that later. But for the time being, this is as far as we can go. Nothing to add. All right, I'm going to do this one first because it's a little easier than this, and then we'll come back to this trinomial here. So we've got a monomial times a binomial. I need to multiply the 2ab times the 3b, and then times the 2a. So 2ab times 3b is going to give me 2 times 3 is 6. ab times b, the a stays, b squared, right? Because this is b to the first times b to the first. 1 plus 1 is 2. And then I'm going to do 2ab times 2a, and that's going to give me 2 times 2 is 4. A times a is the same thing as a1 plus 1, a squared, and the b, can't forget about that. Both of these are positive. We've got 6ab squared plus 4a squared b. These both have a and b. Can we combine them? No, we cannot, because the exponents don't match. Okay, we've got a square and a 1, a square and a 1. They do not match. This is as far as we can go. Excuse me. Okay, so let's try this last one. We're going to take negative 3. Now, this is actually not going to be too bad because there's no variables on the negative 3. We're going to distribute to the first term, to the second term, and to the third term. So negative 3 times 8x squared y to the third is going to be negative 24 x squared y to the third, because 8 times negative 3 is negative 24. Same thing here, negative 3 times 7x, negative 21x. 7 times negative 3 is negative 21. And negative 4 times negative 3 is going to give me positive 12, and the y to the fifth will remain the same. Nothing we can combine, so that's where we stop. The key when you have a monomial outside of the parentheses is to distribute it to anything that's inside, no matter how many terms you have. You have got to distribute it to every single term inside those parentheses. Don't distribute it to the first one and then think you're done. If you have a monomial, a single term outside the parentheses, then you should see different numbers inside in your answer. You should never wind up with identical to the problem that you're given. All right, so let's move right along to a binomial times a binomial. This is just my favorite. Okay, so when you're multiplying two binomials together, I want you to remember FOIL. FOIL is nothing more than a well-organized method of distributing, right? We've got two sets of parentheses. We need to distribute all of the terms to all of the other terms. And the easiest way to keep track of what we're doing and make sure we are doing enough multiplication is the term FOIL. Okay, this is an acronym. I'm giving you a word and each letter stands for something. So the F in FOIL stands for first. The O stands for outside or outer. Either way works. Outside or outer. Okay, the I stands for inside or inner, whatever your preference is. And then the L stands for last. This will be the position of the things that you are multiplying together. Okay? So let's take a look at an example. 2x minus 5 times x plus 6. So these will be the first terms. 2x and x are the first terms in both sets of parentheses. They come first in their sets of parentheses. So 2x times x. Okay, let's label all these first and then we'll come back and do the actual multiplication. The terms that are in the outside position in both of these sets of parentheses are the 2x and the 6. They're on the outermost edges. So that's 2x times 6. Okay, the inside terms, negative 5 and x. This is S. This is O. This is I. The inside, 5 times x. All right. Last but not least are the last terms, the terms that are in the last position in each of those parentheses. Negative 5. Oh, wait, hold on. I forgot my negative here. Don't want to do that. Negative 5 and 6. Those are the last terms. Negative 5 times 6. Okay, so 2x times x, 1 plus 1, gives me 2x squared. 2x times 6 gives me 12x. Negative 5 times x gives me negative 5x. Just mash those things together. And negative 5 times 6 gives me negative 30. Okay, 2x squared. I have no other x squares, so I cannot combine that with anything. That will be part of my answer. 12x and negative 5x. I can combine those. They have the same variables. They are like terms. Okay, so 12 minus 5 is going to give me 7x. And then my constant, I don't have any other constant term with no variable, so that will stay the same. 2x squared plus 7x minus 30. Think we can do a couple more? I think we can. All right. 3a minus 7 times 3a plus 7. So our first terms in the first position, 3a times 3a, that's going to give me 9a squared. Let me scooch this up a little bit. All right, 9a squared. Now my outside terms, 3a and 7. 3a times 7 gives me 21a. I had to think about that for a second. All right, now my inside terms, negative 7 and 3a. 3a times negative 7 is going to give me negative 21a. Uh-oh. Something interesting is about to happen. Okay, and then negative 7 times 7, my last term. Negative 7 times 7 is going to give me negative 49. If I go down the line here to combine like terms, I don't have any other squared a, so 9a squared remains as it is. 21a and negative 21a, well, those just cancel each other out, don't they? That just makes 0, and I'm going to not waste my time and energy writing a 0. I don't have any other constant terms, so my answer is 9a squared minus 49. That's it. Let's take a look at this last one. Ooh, doggy, we got a lot of exponents over here. Okay. First, 4x squared and x cubed. Okay. I'm going to list them again like I did in this example, and then we'll go through and multiply. My outside, 4x squared and negative 6y squared. 4x squared times negative 6y squared. All right. My inside terms, 3y and x cubed. Okay, and then my last terms, 3y and negative 6y squared. Okay, let's multiply all these bad boys. 4x squared times x cubed. 2 plus 3 is 5. 4x to the 5th. All right, 4x squared times negative 6y squared. Well, 4 times negative 6 is going to give me negative 24. X squared times y squared is x squared, y squared. 3y times x cubed. When I multiply these things together, I want to put the variables in descending order within the term. So instead of calling this 3yx cubed, I'm going to say 3x cubed y. And I can do that again because multiplication is commutative. It doesn't matter what order the terms are in. Okay, and then last but not least, 3y times negative 6y squared. 3 times negative 6 gives me negative 18. Y times y squared is the same thing as 1 plus 2, and that's going to give me y cubed. So let's put this whole thing in descending order. I've got a 5th degree, a 4th degree, a 4th degree, and a 3rd degree, so I'm just going to go right down the line as it is here. 4x to the 5th minus 24x squared y squared plus 3x cubed y minus 18y cubed. Not a very pretty answer, but that's okay. We got it done. Can't combine any of that because nothing is the same in terms of the variables and their exponents. So that's our final answer. Those are 3 really different examples, and you'll definitely see all 3 types of problems in practice as well as on the SOL. So make sure you're familiar with kind of all of these different possibilities. And the last thing we're going to talk about in this video is when you have bigger terms than a binomial. Okay? When you have a multiplication problem where there are more than 2 terms in the parentheses, again, you're going to use distribution. But it's going to be a little bit more complicated because you've got so many things that you need to distribute. So it can be easy to lose your place. And my favorite way to make sure that you don't lose your place and don't get all mixed up and leave something out or multiply something more than once is the box method. So you are going to draw a box with the same number of columns Forgot how to spell columns there for a second. The same number of columns as there are terms in the first set of parentheses. Then you're going to draw the same number of rows as there are terms in the second set of parentheses. And if you want to use those interchangeably, that's fine. That's just the way I like to do it. Okay, so if you have a binomial times a trinomial, which is what we have in this example, your box would have 2 columns and 3 rows. You set up your terms so that each term is outside of one of those boxes, and then we'll multiply everything together. So let's see what we're talking about here. So we've got a binomial here. We're going to have a box with 2 columns. I need a ruler. That's cute, okay? And we're going to have 3 rows, so I'm going to try and divide this as evenly as possible into 3 rows. I'm going to put the terms from my first binomial across the top, and then the terms from the second set of parentheses, or the trinomial, down the side. So everybody's got their own box. It's kind of like Battleship. Now we're going to go through and we're going to multiply the thing on the top by the thing on the side and put the product in the box and all the way down. So 3r cubed times 2r squared gives me 6. 2 times 3 is 6. R to the 5th, because we added our exponents. Negative 6r times 2r squared is negative 12r to the 3rd, right, because there's an invisible one there. And 2r squared times 2, 4r squared. Now we're going to do the same thing down this column. 6 times 3r cubed gives me 18r cubed. 6 times negative 6r gives me negative 36r. And then 6 times 2, good old 12. Okay, now if something can be combined, it will live in a diagonal with the thing that you can combine it with. Just because something is in a diagonal doesn't mean it is combinable. You cannot combine 4r squared and negative 36r. But you also won't have to go like searching all over your box like, oh, this can be combined with this down here. No, it doesn't live in the same diagonal. But we can see here that negative 12r cubed and 18r cubed, those are the same. They both have cubed r's, so we can combine them. We're going to go in descending order as we list out our answer. So we'll have 6r to the 5th. 18 minus 12 is going to give me 6r to the 3rd. Then I've got 4r squared. And you can go through and cross these off as you're using them, so there's no confusion. Minus 36r plus 12. And that's the answer, folks. It's a long one. So as you can see, it's the same thing as saying I'm going to say 2r squared times 3r cubed, 2r squared times negative 6r, 2r squared times 2, and then 6 times 3r cubed, 6 times negative 6r, and 6 times 2. It's just a little easier to keep track of what you're doing when you have it in a box versus just drawing the arrows. I will not judge. You can do whatever method works best for you. I'm easily distracted and I look away from my paper quite often, so this is better for me than this. I can move my spot too easily here. But again, as long as you're showing me some kind of work and getting the right answer for me, I want you to do what you feel most comfortable with. So those are all 4 of the different methods of multiplying polynomials that we're going to talk about in class. We're going to do a ton of practice tomorrow. And then the last video we have for this series will be division of polynomials. So stay tuned for that one. Write down any questions that you have, and I'll see you tomorrow in class.